Alright. Hello everyone. This video is from my series on symbolic logic, or called mathematical logic, sometimes called formal logic. And this lesson is on two-column proofs. To be successful in this lesson, you have to have a little bit of background of intro logic. So you need to be familiar with terms like conjunction, disjunction, truth table. You need to know your argument forms like modus ponens, modus tollens, hypothetical syllogism, and you need to know a few basic equivalences such as De Morgan's law, disjunction to conditional, negating a disjunction, and so on. So let's get right into the examples. It says to rewrite the argument in symbolic form, check the validity of the argument. Remember that argument form lists the premises and the conclusion. So this says the space shuttle landed in Florida or it landed in California. Let's call that F, or, and it's saying landing in California is, looks like it says the letter O, but I'm going to use the letter C. Again, C just stands for it landed in California, the statement. If the space shuttle landed in California, then the alternate landing schedule was used. So if C, then A. We have one last premise. It says, but the alternate landing schedule was not used. So not A. Again, premises are things that we assume are all true. We're going to try to come to a conclusion based on some logical relationships here. This conclusion says, therefore, the space shuttle landed in Florida. So that would be the statement F. We list out two columns, one for the steps, and then one column to give the reason or sort of the justification, how we came to that conclusion. So we need to number everything. And the good thing about two-column proofs is your first statements are always just a restatement of your premises. So premise 1, premise 2, premise 3. We've got F or C. If C, then A, and not A. Okay. From there, we need to either use logical equivalences, or we can form a conjunction between any two statements and then go from there. Let's take statement 2 and 3. If you know your argument form for modus tollens, you can see that we can set up a conjunction here, and that is a very important step here. We're going to do a conjunction between 2 and 3, statements 2 and 3, and that perfectly sets up an argument form for modus tollens. Why? Because we have a conditional statement and we have the negation of its consequent. So modus tollens says because of if C then A and not A, it implies not C. And if you notice, as we use the statements, we're going to cross them out each time. We've already used all the information from statements 2 and 3 and 4. So we need to go off what we have here, not C, and then statement 1, F or C. Let's go ahead and turn statement 1 from a disjunction into a conditional. So to do that, we have to take the negation of the antecedent. We keep the same order. We take the negation of the first one, it becomes the antecedent. Now, why is that possible? Because of the law of disjunction to conditionals. That's an equivalence law. We did it to step 1, to statement 1. We can mark that off. Okay, so we have this information. Let's make a conjunction here. All right, if not F, then C, and not C. That's a conjunction of 5 and 6. Again, we set up a perfect argument form for modus tollens. Apply modus tollens to step 7, and we get the conclusion is the negation of the antecedent. So the negation of not F is F. And that was the conclusion that we were going to find. So this is a valid argument. we've proven it's valid with a two-column proof. Okay, let's start with this good problem here. You want to have a column for your steps. You need to have a column for your reason that you're doing these steps, but if you're arriving at these conclusions. And you do have to number everything as you go. Let's go ahead and set this up in argument form. So premise 1 is if D then L. Premise 2 is if L then E. Premise 3, there's not going to be a presidential election. Conclusion, no 28 days. Good thing about two-column proofs is your premises are always where you start. Start with the premises. You basically just list all those. We can also put the word given. Say that these statements were given to us, and we were told those were true. And then from here, what we can do is we can take conjunctions of any two statements, and we want to use rules like modus ponens, modus tollens, contrapositive, any sort of equivalence laws or argument forms that we know to arrive at certain conclusions. So here's something that we can do. We can take premise 1 and premise 2, and if you know your patterns for argument forms, you know this we can actually do a hypothetical syllogism with. We're not doing the hypothetical syllogism yet. We need this step in between to state. Very specifically state. We're taking a conjunction of statements 1 and 2. We've pretty much combined that knowledge into one statement. You can cross out statements 1 and 2 because we're not going to use those anymore. We're going to use statement 4 instead. And then we can go ahead and perform a hypothetical syllogism on statement 4 and use that rule. This L sort of gets forgotten about. We jump to the conclusion. If D, then E. Based on hypothetical syllogism, we've used that to cross it out. And we only have two facts left that we haven't used. Premise 3, which is not E, and then this conditional is D, then E. Conjunct those. And it's not E. Make sure we put that down as a step, the conjunction of 3 and 5. And then that pattern right there forms the argument of modus tollens, since we have a conditional and then the negation of the consequent. So based on modus tollens, we can infer the negation of the antecedent, not D. And that's your answer. We used everything. Everything's crossed out. We've arrived at the conclusion that we wanted to arrive at. So we've proven with a two-column proof that it's a valid argument.